Alright, I'm running a test for Dr. Stiffler. He's asked for a replication of his 6 volt 9 LED SEC 18 setup that rejuvenates the or recycles the energy back into the battery. And I've set up sort of a little spreadsheet here to show the different days run and the date that it's going and the time and the voltage on the 6 volt battery. And some other guys are doing this, and I'm doing it also. And this is Little Beam's father. And Little Beam is a handheld spotlight that Dr. Stiffler has converted to his SEC that will run over a week on a 6 volt battery. And this is the 5-day test, and I'm going to run this for 5 days, checking voltages as often as I can, but it looks like I'm running about every 12 hours, which I don't think the doctor is going to be upset with. And you can see the voltage drops here. It dropped pretty quick the first 12 hours, and it settled into a very low drop. And this is the setup, and this is as close to an exact replication as I could get of Dr. Stiffler's setup. And it is 9 LEDs, 6 on a positive rail, 3 on the negative rail, with this L3 coil driving it through an AV plug, which is right here. And then as it goes through these 2 rails, the energy is fed right back into the source, right there. This is a 6 volt battery. It is exactly what he used. It's a 6 volt 4.5 ampere hour battery, and I did charge this up a little bit more than he did when he started the experiment. I think that's why I had the drop right here. But I'm going to run this for the 5-day run and checking voltages as it goes. And these LEDs are pretty darn bright, folks, for that amount of energy being pulled out of that battery. Now I measured about 8 to 9 milliamps, which is very low. He is running his at about 11 milliamps, which I could adjust this to that, but the adjustment I have here is about 8 milliamps. But I'll continue the experiment and report back on how this ran for the 5-day run with those 12 LEDs being run by the SEC 18-1. Now the other thing I'm running right now is an experiment with a 15-3. Now this is the home built one that I did here, and you can find the circuit online pretty easy. And this was shown in my last video with this solar cell charger for a cell phone. It's a solar charger with a lithium battery inside it. And I showed in my last video how that if you turn this up toward the light, you can make the charge light turn green. And I thought, boy, that's great, it's just going to run on its own. But it was a false reading. This is actually pulling energy out of the battery. The green light goes on showing that energy is going in, but it doesn't show the amount going out. So it actually ran down and stopped at about 5 1/4 volts. After less than a day's run. So that experiment was not totally successful, but I did learn a lot from it. And I think this was a pretty good idea. You just set this out in the sun every day and charge it up, and then at night you'd have light. And if you wanted to extend the run time, you could hold this up against the LEDs, and it does extend the run time, but you lose the light, of course, because it blocks out the light. But anyway, that was the second experiment that I've been running, is that SEC 15 using that little solar cell phone charger. And that's the second part of the experiments that I'm currently running. But this was the primary one right here, and I did want to report that I am running this experiment for Dr. Stiffler. Thanks for watching.